Mic check, 1 2 1 2. Here we go. Mr. Longo here, and we are going to be working with the greatest common factor. So a lot of times when you're working with factoring, the first thing you should do is factor out a GCF of the entire expression. So to do that, you just have to ask yourself, what can you evenly divide out of everything that is in whatever you're going to factor? So the first one, what you want to do is first you have to look and see if you have numbers and variables to take out. This one has an x squared, this term has an x, this one does not have an x, so you cannot even consider factoring out an x. So now we're just going to look at numbers. We have a 2, a 6, and an 8. And the largest or the greatest common factor we can take out of all three of those terms is a 2. They are all divisible by 2. So 2x squared divided by 2 is just x squared, plus 6x divided by 2 is 3x, and 8 divided by 2 is 4. And that's it. You're done with that problem. So what you basically do is divide everything out by the greatest common factor, and whatever's left you leave inside. Keep special note in mind. You must always make sure that you have the same number of terms that you begin with. So we began with 3 terms. We still have 3 terms on the inside. Okay? Next example. Look through this. We have an x cubed, an x squared, and another nothing. So we cannot factor out any x's. If you look through again, we can factor out a 3. So you would just say 3 times 6 divided by 3 is 2, and of course x cubed. Plus 3 divided by 3 is 1, and we have our x squared, minus 9 divided by 3 is 3. Okay? So that's pretty much the idea. You just want to make sure you can factor something out of each. Now this next example has x's and y's. So we'll do this one together, and then the last one is for you. So we have 4x squared y. We have an 8xy squared and a 2xy. Now we're talking about the greatest common factor. Now the 2 is our GCF for the numbers. But now we need to look, we have an x squared, an x, and another x. You have to evenly be able to divide a variable. So you can't take x squared out of x, but you can take x out of x squared. So x is our GCF for the x variable. Same thing's going to happen. We have y squared, and another y, so all we can take out is a y. So now you just have to divide it all out. So go ahead and pause the video and see if you can factor out the GCF from all 3 terms and see what you have left inside. 4 divided by 2 is 2. X squared divided by x is x, and y divided by y is 1. It goes away. Minus 8 divided by 2 is 4. X divided by x goes away. Y squared divided by y is y. Plus 2 divided by 2 is 1. X divided by x is 1. Y divided by y is 1. Now you would think it might go away, but you have to put a placeholder of 1, like I said. If you have 3 terms to begin with, you better have 3 terms inside. 2xy divided by 2xy isn't nothing. It's 1. Just like 5 divided by 5 is 1. It's not nothing, so you have to keep it with a 1. Last example is all yours. Pause the video and see what you get. So you should have factored out an x squared. That's the only term you can factor out here. 3 does not go into 5 or 7. Neither does any other number evenly. However, you have an x to the 5th, an x squared, and an x cubed. So the only one you can take out of all 3 would be an x squared. So now we're going to have 5 x to the 5th divided by x squared is x cubed. X squared divided by x squared is x, but we still have our 3. And then we have 7 x cubed divided by x squared is just x. Okay, and that's it. That's how you factor out a GCF, or a greatest common factor. That's it for this video. This is Longo, and I'm out. See you, bye.